Hi, Haley. Hello, Shane.
Hi, how are you?
Good, how are you?
Not so bad.
Okay. And I see Haley's also on here. Hi, Haley. Guess our microphone's muted. All right, so for this week, we have two chapters that we're covering, chapters 8 and chapters 9. And before I go into discussing either, did you have any questions?
I do not.
Okay. All right. So for let me share my screen here. And I'm going to go, so for chapter 8, I made a video and posted that video to Blackboard. And I wanted to focus more on chapter 9, but let's go ahead and look here to see if there's anything that I really would like to emphasize. We are on module. Okay, so chapter 8 talks about location strategies. And the takeaway from this chapter as you go through this is just basically why is it important to have a good understanding of the processes that are involved in citing a given facility. Let me record this just for the sake of those who aren't here. Oh, it's already recording. Okay, so location decisions are very important because they usually come with a pretty hefty price tags, and often if we make the wrong decision with regards to the location of a warehouse or of a retail location or even of an office, it becomes very costly to then pull out and try and move that facility to a different location. Okay, so for chapter 8 and what I discussed in the video, what are the different things that you need to know to be able to figure out what's the best possible location for whatever type of facility that you're seeking to get a location for. Okay, so as you go through this chapter, try and make sure you understand how to go about calculating, how to use these three different approaches that we have here to try and determine the best location. Okay, get to know what's the center of gravity method. Okay, how to go about doing a break-even analysis for a given location, and then what's the factor rating method. Okay, the thing to know with this is that the three approaches here are all very easy to use. You can do it on a piece of paper. I prefer if you're doing your math, you do it in Excel because it's much easier to create a template and reuse it over and over again. Okay, but I'll just briefly touch on those different location siting approaches that we have here. Okay. All right. So when you're making a decision on where to locate a facility, and let's go with a manufacturing plant. Okay. One of the biggest considerations you have to make is where do you want that location to be? Do you want it local and the benefits to that, or do you want to to possibly go global and look for location outside of the United States? Okay, and a lot of companies have found financial benefits to that as well, usually in the form of lower labor costs but it also comes with a higher risk associated with a much wider supply chain. So there are a whole bunch of issues that go into, first of all, figuring out where should we site this relative to our competition. Okay, for a lot of industries, if people within a given industry find it convenient to locate plants outside of the country, then for those coming on board, they would then consider, should we do the same to also capture some of those cost benefits that might go with that? Okay. Over the past 10, 15 years, there's been this increased emphasis on, can we bring back some of those location decisions and have locations for plants for different facilities within the continental United States? And the benefits to that, as well as disadvantages to that, which might include higher labor costs. But those are things that you as a manager has to take in consideration. And they're even they're non-monetary factors that go into this, including things like patriotism and a whole bunch of different things like that. Okay. So once that decision has been made to either locate locally or locate globally, then we go into this review of all the different pluses or minuses or the pros and cons for a given country. And once we've made the country level decision, then we go down to a slightly lower level, which is like within a given country, where exactly do we want to source or to site this given facility? Okay. And those regional decisions kind of tie into what benefits are there to siting a plant within a given state or a given county. And there could be issues such as tax incentives given by the government. There could be costs of labor being lower in one state than in another. There could be that one state has less environmental regulations, which make it easier to set up a plant without having to worry too much about the environment. And all these things have to be considered prior to finally narrowing it down to the last decision level, which is within that region, where exactly are you going to site your plant? Okay. So this is more county specific in many instances. And again, you're looking at, do you have access to the type of infrastructure that you need? Okay. Do we have access to a rail system or to good highways, if that's something that's important to us? And so at the site level decision, we're now looking at more localized laws and trying to figure out what are these laws which might impact our ability to operate as a business. Okay. So I'm going to go into the different calculations of that are associated with location decision making. Okay. Because I'm assuming that a lot of the theory is things that even if you're not working, if you don't work in operations management, they should be things that are pretty much common sense and easy to understand. Okay, so let's start off with the factor rating method. Okay, when you decide to make a location decision on the basis of the factor rating method, you're basically trying to figure out what are the different things that we need to look out and make sure that we capture that will lead to the success of this specific location, and in tying that success to the overall objective of our organization. Okay, so for the person using a factor rating method, you have to come up with a list of what we call key success factors. Okay, and for every key success factor, you have to determine some ranking, some level of importance for each and every one of those key success factors. Okay, and then once you've come up with that ranking and determined what's most important to your to the location success, then you can compare multiple locations on the basis of those key success factors. Okay, so let's look at the example here. Let me see if I can copy this into No, I'll be able to copy this into a spreadsheet. I find it easier to work in a spreadsheet. So in this case here, for this organization, they were looking to site a plant in one of two countries, either France or in Denmark. And so they wanted to compare these two nations as potential sites for their plant. And so they decided to come up with a bunch of key success factors. In this case, the availability of labor, the people to car ratio, the per capita income of the people, if that's something that's important for the sake of the people or customers being able to afford the product that's being sold. And then they also looked at how friendly is the tax structure of each country. And finally, the last thing they scored each other on was on education and health outcomes within a given nation. Okay. So once you've come up with those key success factors, you have to assign to each and every one of these a weight based on what you think makes the most sense to be given the most weight. Okay. And looking at the table we have here, it seems that the tax code of the countries plays a very significant factor. And so they decided to give this a weight of close to 40%. Okay. And that's followed by the availability of the kind of labor they need, and then the levels of education of the people there. Okay. So the one reason why I find the factor rating approach method a bit biased is that it's subjective in nature. Okay. The weights that are assigned here are pegged to the person who's making that assessment about each and every one of these key success factors. Okay. So it's subjective such that if your weighting scale is not correct, then your scores might result in something that's not very accurate. But it's still a great way and a very fast way to try and determine what location or what nation should we site a given plant in. Okay. So if you come across a question like this in your homework assignment, I would advise you copy this and paste it in Excel just for the ease of being able to very quickly calculate how well each and every one of these locations is doing on each and every factor that we have here. Okay, so in this case here we had 5 success factors, 1, 2, 3, 4, and 5. And I just want to make sure that we're on the same page in terms of how do we very quickly do this in Excel. Okay, so you get your key success factors, you get your weights, and as I said, that the weights are usually subjective, but your weights have to sum up to 1. Okay, if they don't sum up to 1, you know there's something wrong with your calculation. In this case here, our weights were given as 0.25, 0.05, 0.1, 0.39, and then 0.2. Okay, and then you go get data, or find some information about those two locations on each and every key success factor, and you give them a rating, you give them a score. Okay, so we have France and we have Denmark. And the simple calculation we have here will just be to multiply every weight by every given score we have here. Okay, and you come up with France's weighted score, and then we have Denmark's weighted score. So we had a scoring of 70, 60, 50, and 60, 85, 80, 75, 70, 60, and 70. Okay. You could do this on a piece of paper, or you could just simply decide that it makes more sense to just use a sum, to use a sum product to get this weighted score for each. Okay. In the textbook version that we have here, each weight is multiplied by each score, which is fine. But I would rather just use a sum product function and just multiply, do those sum product and multiply these weights here by the corresponding scores. Okay, and you come up with that calculation that you'd have had to go through multiple steps to get to. And I'll do the same for Denmark. And here we'd have the sum product of the weights multiplied by the scores. Okay, so with that, we then look to see which one has a higher weighted score, and we say that the one with the higher weighted score becomes the location which is more attractive to us, because that location meets our criteria of our key success factors at a higher level than the other location. Okay. So as you see, it's a very simple, straightforward way of trying to figure out where to site a plant or site some facility, which doesn't really require so much advanced math. Okay, so that's a factor rating method. Let's go to a slightly different example here. Okay, so here we have an example where we have 3 locations, Athens, Brussels, Lisbon, that we are trying to compare. But now we're comparing them on the basis of just one aspect. We're comparing them on the on 2 aspects, the cost associated with every location and the expected revenue that we expect to receive from each and every location. Okay, so I'm going to copy this table here. And I'm hoping that you all have done a break-even analysis at some point in your careers. Okay. But even if not, let's go ahead and do it together here. Okay, so we have 3 locations here, and we're trying to figure out which of these 3 locations should we set up a plant in, okay? And we've also been given information about how much selling prices and expected volume of product once we start selling product, okay? So the break-even analysis approach tries to look at what's that point where our total revenue coming in just exactly equals the amount of total cost that we've incurred, right? So if you're looking at a break-even formula, you will have your total cost for a given location being equal to your total revenue. Okay. So for you to be able to use this approach, you need to know what are your costs, what are the different costs, and the costs are usually divided into 2. There's fixed cost, and then there's a variable component. So there's a variable cost as well. Okay. So your total cost is the sum of the fixed cost plus your variable cost. And we're saying that this should equal your total revenue or your total money that's coming in, okay? And the total money that's coming in is a function of the price of your product. Let's say that's P, multiplied by the volume that's being, that you anticipate selling, okay? So your fixed cost is usually going to be a given. It's going to be a fixed figure. What we don't know is the variable cost, the total variable cost, because the total variable cost depends on how many units you're selling, okay? So the true formula for the total cost will be your fixed cost plus your variable cost multiplied by your volume, okay? Because if your variable cost is $1 per unit and I sell 2,000 units, then my variable cost will be $2,000, okay? So let's keep that in mind and let's go figure out what's the total cost going to be when you have an expected volume of 2,000 units here. So let's have this as total cost. And my total cost here is going to be, it's actually already given. Yeah, so the total cost here is just basically your fixed cost plus your variable cost of $75 multiplied by the total number of units you plan to sell. And that's what gives you the 180,000 that we have here. Okay. And now we want to compare. This tells us basically what our volume is going to be at break even. Okay. Because we're saying that at break even, we are going to incur the highest total cost at break even if we decide to go with the Athens plant, or we go with Athens. The lowest cost would be at Brussels, and so on and so forth. Let me get rid of these writings here. Okay. And now we're trying to figure out what we call our crossover point, because we're not just interested in knowing which location has the lowest possible total cost and so on and so forth. We might also be knowing within what range would Brussels be the best option for us? Within what range of volume should we consider having Brussels as our manufacturing location, for example, okay? And beyond a certain range, you'll find that Brussels stops being the best possible location for us to produce at, right? So let me explain that. Let's look at a situation where instead of producing 2,000 units, let's increase that volume to, let's say I was projecting that we're going to be selling 3,000 units. Okay, and if that was the case with this new volume, our total cost would be our fixed cost plus $75 per unit multiplied by 3,000. Okay, now you notice something happens here. If our volume ever increases, which you expect for a business that is up and coming, that's growing, that the volume of sales should increase. Now we have a slightly different situation here. And the situation is that our total cost that was lowest for Brussels is now lowest in Lisbon. Okay, so that's another scenario here. So let's say that's volume of 3,000. Now let's try one more level of volume, and let's try 1,000 units. If we think that possibly sales might not pick up as well as can be, and we want the lowest possible cost location, we'll have 30,000 plus 75 multiplied by 1,000. Okay, now notice that I become indifferent between these two locations here because the price is the same. The total cost is the same. And so we break even at around the same point, okay? So why am I doing this? I was talking about what's the crossover point? At what volume of product does it make sense for us to consider moving from Brussels and having our location in Lisbon, okay? Because if I think that our business is going to grow and expand, Brussels might not be the best possible option for us long term. It might be good for us right now when we have only 2,000 units of product being sold. But if the company is expanding, you find that we might have a cheaper location elsewhere. But I want to know what's that crossover point where we are indifferent between Brussels and Lisbon. Okay, so that crossover point or that crossover volume is what we're interested in knowing. And the crossover volume will basically be the volume at which the total cost at Brussels would equal the total cost in Lisbon. Okay, so total cost at Brussels. Let's start with Brussels here. Our total cost for Brussels would be a fixed cost. Make this bigger. So if we start with Brussels here, I'm going to say that there's some place where our fixed cost would equal 60,000 plus our variable cost of 45 multiplied by some volume, which as of yet, I don't know, because I'm trying to figure out what amount of volume would we have where our total cost will be the same in Brussels as well as in Lisbon, okay? So we have Brussels and the same is going to apply for Lisbon. And we're saying that there's some point where this fixed cost of 110,000 plus 25 multiplied by whatever volume that's going to be, these two values here are going to be equal, okay, at some value of V. So now we have to figure out what's this value of V, okay? And so you do your basic math to determine what that will be. So we have your 60,000 plus 45 V at break, that crossover point. This value here is going to equal 110,000. Yeah, I think I didn't get that right here. So that'll equal 110,000 plus 25 V. Okay. So now if we get the like terms together, we can try and figure out what's this volume of V where we've been different between Brussels and Lisbon. And so I'll do this and say 45V minus 25V equals 110,000 minus 60,000. Okay, so what do we have there? So we have 20V equals 110 minus 60,000, that would be what, 50,000? So our V would then equal 50,000 divided by 20, which would be at a volume of 2,500 units. Okay, so if we get to 2,500 units, the cost of the total cost in Brussels would equal the total cost in Lisbon, but any volume of sales above 2,500 units will result in Lisbon being a better option for us than Brussels. Okay, so let's try that by adding off one final column here. And let's have a volume at 2,500. Okay, and let's start again from the top here. And here our total cost will be 30,000 plus 75 multiplied by 2,500. Let me drag this down. What happened here? Oh, sorry. Should have clicked on the cell. Okay, so at volume of 2,500, our total costs here are the exact same. But if my volume was 2,501, then you'll find that the cost starts dropping. And this is what we end up with. Anything above 2,500, Lisbon becomes a cheaper option. Okay, so that's what we talk about when we look at what's a crossover point. Okay, the crossover point is just basically that. The point at which we're indifferent between two locations, but at the same time, it's also the point where we start to answer the question of where would we where should we site our location if we expect our sales to grow? Okay, so Brussels might be cheap initially, but if we're expanding, then we end up with a situation where Brussels is no longer the best option for us. And it then might make sense for us to start or site our plant in Lisbon from the get-go. Okay. And the crossover charts would look something like this, where you have the different cost curves for each location. Okay, where you can now compare and contrast and ask yourself, if we expect our volume to be a certain amount over the next 5 or 10 years, where should we site our facility? Okay, so it's a great way of analyzing different options on the basis of cost as well as revenue coming in, and definitely a tool that an analyst could use to try and come up with the best possible location. All right, the center of gravity method. The center of gravity method is also a really great tool, okay? Because it tries to site a location based on weights, based on volumes that move from a given location to, say, for example, different customers, okay? So let's look at an example of this. And it's a kind of like a geographical information system way of figuring out where to site your location, okay? So when you're talking about the cost of the center of gravity method, we're trying to figure out for any given location that we would consider having as a location for a plant or a distribution center or an office, how much volume do we anticipate leaving that location to go to the different customers, okay? And how much cost or how much distance would be covered to get from that location to a given location, okay? Now, the center of gravity method uses a grid system. So we're basically looking at something that looks like this. Actually, let me add a spreadsheet here, and I want to have a blank sheet. Insert, new slide. All right, so let's assume that, let me try and draw the map of the United States. And you have to pardon my drawing skills because I'm not an artist. But let's assume that this is a map of the United States, and we're trying to figure out if we have customer 1 here, we have another customer over here, we have another customer possibly down here. Maybe we have another one somewhere here. And let's say we have another one over here. And the question is, where should we locate our distribution center such that we incur the least possible cost to get products to each and every one of these 5 locations? So the center of gravity method basically puts this map here onto a grid. Could be an arbitrary grid that looks like this. You can have its origin anywhere, okay? And we're basically interested in if our origin, let's say our origin here is 0, okay? And we have our x-axis here, we have our y-axis up here, and we're basically trying to see for each location that we have here, the first thing we need to know is how much volume of product do we ship to that location in a given year, okay? So I need to know the volume for this location, I need to know the volume for this location, and I'm going to multiply the volume of this location. So the volume becomes weighted based on place with the most volume would get the distribution center put closer to it, okay? So if we had it such that this place here had 1 million tons of product coming in, but the rest had just 1 ton, the center of gravity approach will have me have a distribution center somewhere near where we have a whole bunch of stuff going to, okay? And so let's see how we go about doing this mathematically. Again, it's very basic math. It shouldn't be that hard for you guys to do this when you come across it on a homework assignment or in an exam. Okay, so let's look at Quain's Discount Department Store, and they have 4 locations where they have stores. So Chicago, Pittsburgh, New York, and Atlanta, Georgia. And they have a certain amount of volume. So they have 2,000 containers going to Chicago every month, 1,000 going to Pittsburgh, 1,000 to New York, and 2,000 going to Atlanta. And we want to try and figure out, where should we site a distribution center, for example? That's going to take into consideration these weights here. And the second component that we need to figure out is the different distances. Okay. So now we use the grid approach, and the grid approach requires you to have distances on the x-axis as well as on the y-axis, okay? And everything is centered around this origin that we have here. And remember, it's an arbitrary origin, so it doesn't matter if my grid was over here, or I plotted it from like over here, okay? The result will be exactly the same. So you have an arbitrary origin from wherever it is that you want to plot it for, and then you're going to calculate the distance from that origin to that given location along the x-axis, and do the same along the y-axis, and you come up with a set of mileages. Get rid of this. Okay, so for example, if you look at Atlanta here, Atlanta is 60 miles from this origin that we have here, going east of the origin, and it is 40 miles going north from our origin. Okay, so now we get our x coordinate, which is 60, and a y coordinate, which is 40. And we also need to know the volume that's going to Atlanta. Okay, and the combination of the distance and the volume will give us a calculation for where we should site our distribution center. Okay, so keep that visualization of a grid with the different locations in mind and the distances traveled, as well as the volumes that we expect to go to every location. And on the basis of that, we can now make our calculation of where should we site our distribution center. Okay, so how do we go about doing that? Let's go back here and look at the different locations we have here. And let's start with Chicago. Okay, let me bring out my pencil again. So Chicago is 30 miles due east of our origin. So let's start with Chicago and say that our x value, let me do this. Our x value for Chicago is 30. Our y value for Chicago is 120. Then we have Atlanta, where we have our x value being 60 and 40 for the y value. Then we have New York, that's 130 and 130. And finally, this Pittsburgh, that's at 90 and 110. So when you're calculating the center of gravity, you're going to take every axis, you do each axis one at a time. So we start off with the x-axis, and we take these values here, and we multiply them by the amount of volume that we expect to go to that specific location, okay? So we know that to Chicago, from the table we had there, there was a total of 2,000 tons of product, I believe it was tons, going to Chicago. Let me do that, get a better. Okay, so we have 2,000 tons of product going to Chicago. I'm going to multiply that distance of 30 miles times 2,000. And then I'll go to the next location, say Atlanta, and I'll do the same thing. Atlanta was 60 miles, so I'm going to add this. 60 miles multiplied by however much tons, whether it was 1,000, I believe, plus go to the next location and so on and so forth. So we get it's kind of like we're weighing the amounts that are going to every location. And once we're done with that, we divide them by the sum total of all the different tonnage going to all the 4 locations. Okay, so we have Chicago, multiplied by the total volume, the miles multiplied by volume, miles multiplied by volume, miles multiplied by volume, and we divide everything by the total volume. And that gives us a number here. Okay, and this number here is our x coordinate for where this new distribution center should be. Okay, then we do the exact same thing for the distances going northwards. Okay, there's a distance of 120 miles to Chicago from that arbitrary origin. I'll multiply that by the total number of tons going to that specific location and do the same for all 4 locations. And again, we divide everything by the total tonnage expected weekly. And then that also gives us a y coordinate. So our center of gravity then becomes located at this location, 66.7 miles east and 93.3 miles north. Okay, and if we go back to our map, that'll be 66. Get my pencil out one more time. 66.7 and 93. So we expect that we're going to have a warehouse somewhere here. Okay, on the basis of the information we have available to us, the best place to locate a warehouse would be somewhere at that coordinate there. Okay, so after you've come up with that, you have to go and see, or where exactly is that coordinate pointing to. Okay, chances are that it won't be anywhere near. It could be in some farmer McDonald's farm or somewhere that's in the middle of nowhere. So it's not an exact science. It puts you in the vicinity of where you need to be, but the analyst would then have to look around and see where exactly do we need to place or to site this location with regards to access to infrastructure like roads, rail, electricity, water, and things like that. Okay. But then again, this should be something that's not too hard to calculate once you understand the whole grid process that goes here. Okay. Any questions up to this point? All right. So I have a video on this on Blackboard that you can reference, and hopefully to emphasize what I just spoke about here. But I wanted to talk about chapter 9 as well. Okay, so we now move from the location strategy, here's my chapter 9, and now we look at layout strategy. Okay, so we started, the reason why I combined these 2 chapters together is because they're both focused on something similar. After you've determined the location and decided exactly where it is that you want to site your plant or your warehouse or your distribution center, the next activity that needs to be done is to figure out how we're going to have the layout of this facility. Okay, and that's another decision that's very important to for organizations to consider. because the way that your space is laid out will determine to a great extent the level of efficiency that you can have in your processes. Okay, if you have a facility that's not well laid out, chances are that there'll be unnecessary movements, there'll be unnecessary misplacement of product. There could be a whole bunch of different injuries if industrial incidents is possible. So the layout of the facility is also just as important as locating the facility in the first place. Okay, so chapter 9 goes into different things that you need to understand about layout spaces for offices, for warehouses, for manufacturing plants. Okay, so the different approaches to this, and it all depends on what's the focus of the layout that you're trying to achieve. Are you trying to have it friendly to customers, or is it more geared towards employees, or is it more geared to having different equipment next to each other? So the different things which are considered important, and it's important for the strategist to understand for this given layout, what's most important to us. Okay. So much as we're discussing this, for the most part, layout strategies are usually done by an industrial engineer. It's somebody who's studied ergonomics and studied different aspects of layout design. But as a manager, a potential manager of a plant or of an office or a distribution center, it's good for you to have an understanding of what goes on in making those decisions with regards to how your plant or your warehousing space is laid out. Okay, so let's jump into some of the different things that I think are important here. So the different layouts, I'll speak briefly about some of them that I think are worth taking note of. And as I said, for every layout, your objective has to come to the front. Are you interested in having a layout that's friendly to customers? Are you interested, if it was a supermarket, for example, in having customers exposed to certain products, okay, more than other products? And you'll see that in the way that supermarkets are laid out. Warehousing, it has to do with a lot of retrieval and putting away product. How can we better manage that whole process within the space that we have? Okay, so let's look at this. This is an interesting piece of art. Okay, and the Mutha grid is used when you're trying to figure out how best to put the different activities within an office space together. Okay, you can also use it within warehousing space or distribution space, but basically it forces the strategist or the industrial engineer or whoever it is who's tasked with putting together some office space to do it in a way that makes the most sense. Okay, and so the Mutha grid has certain codes that you have to factor into your whole decision of what goes where. Okay, and every code is associated with a level of importance for a given connection between different activities or different departments. Okay, so let's try and understand what we're looking at here. Okay, if you have any activity that's coded A, the Mutha grid basically says that that specific activity has to be close to another given activity. Okay, so if you look at this software firm here, I have an A between these two. Let me bring out my pencil. I have an A right here between marketing and operations. Okay. What that means is that the strategist or the planner here has deemed it critically important that the people in marketing be close to the people in operations. So within the office environment, as you're planning your space, what that translates to is that if you have an office that looks like this and your marketing guys over here, you should have your operations guys close by. Okay. And I also see another A over here. And that tells me that the guys in operations should also be immediately right next to the people in accounting. So the way to read this is there's a connection along this diagonal scale where operations and accounting should be close to each other. So I'm going to maybe put accounting here, bring the tables and all that and put them next to operation. Okay. Do we have any other A's? So whenever you're putting the method grid together, you start off with all your A's and make sure that your A's are side by side or attached to each other before you move on to any other letter code. Okay. So the next A I see is down here where it says the guys in graphic arts should be near IT. So it could be that this is our graphic design department and I will have IT next to them. So they should be together. Okay. And it also tells me here that our people in graphic arts should be near people in social media relations. Okay, so I'd have my social media team somewhere there. Okay, and that satisfies all the A's that I have here. I have all my A's right by each other as they should be. The next step is to go down and figure out what else, what's on our second level, our especially important activities, not as important as our absolutely necessary activities, but also pretty important to have next to each other. Okay, so in this graph here, I see an E, two E's actually. So there's an E between graphic arts and the lounge. So graphic arts and the lounge. So let's maybe put the lounge here for now. And there's also a link between the lounge and operations. So this should have been connected to each other somehow. Lounge and operations, I don't know why the lounge should be near operations. Maybe the people in operations like spending time doing stuff in the lounge, okay? But I'm hoping that you see here that slowly by slowly you're putting together the different pieces and putting the different activities or different departments that need to be next to each other, right by each other, okay? The third level, the third code we have is an important connection. And those now could be, they're not as important as A and E, but it's good to have them near each other. Okay, so I see marketing and graphic arts in this graph that I have here. Marketing is over here, graphic arts is over there, which is not a good fit, but it's not absolutely necessary. But since this is my first pass through, I might decide to change this, tweak this a bit, and maybe have graphic arts somewhere here in the second pass. And next to that, I could have S over here and then I somewhere there and so on and so forth, okay? So hopefully you're seeing the different connections that I have that slowly bring together that office space in a manner that's going to make it most convenient for the people who have to work together. And for those departments that don't need to be next to each other. For example, we have a U over here, basically saying that the people in the lounge, I mean, the lounge area doesn't need to be anywhere near accounting. I guess the accounting guys never use the lounge. So that's a connection that doesn't have to be near each other. So that then says we really don't really need to have any connectivity between those two. The second and important activity I have here is the connection between the graphic arts department and accounting, okay? So could be that they have nothing in common. There's no need for them to be near each other. And in terms of our planning, we don't have to consider any connectivity there, okay? So the method grid just enables us to very quickly put together a basic plan of the layout of that given office in a manner that's going to pull together those activities that need to be next to each other, okay? As I said before, if you have any questions, feel free to jump in. but it's a good visualization, something that's hopefully is very easy to understand and very easy to implement for those who ever find themselves having to do an office relationship chart. Okay, so there's the what we had on the chart that dealt with proximity, but there are also additional activities that might require different levels of privacy. That's a very big consideration for most companies. And we also have the issue of permissions and access to a given office that also has to be considered. Okay, that's where you might have a reception area acting kind of as a gatekeeper to who can come into a given space, or it could even be a security office or something like that. Okay, so an office space layout is different from what you'd have in a retail environment. Okay, because the retail environment is now more focused on the external customer. The office space was more focused on the internal customer relationships, so the different departments being customers for other departments. Now we're interested in how do our external customers experience our enterprise from the moment they walk in. What can enable us to achieve our profit objectives while enabling our customers to access the products they need in a manner that's convenient to the customers as they walk in. Okay, so supermarkets are usually laid out in a manner that we might not ordinarily think about it whenever we walk into a supermarket, but there's a method to how supermarkets are laid out. Okay, supermarkets usually require that items that people grab quite a bit be in locations where it'll be easy and convenient for them to access those items. Okay. In addition to that, they have certain locations within the supermarket which are usually located to the different suppliers based on some kind of a priority system. And this priority system could basically be, could even just be the suppliers willing to pay a premium to have their product be displayed first within a given aisle. And so in that instance, it might not be the customer's best choice, but more a matter of the customer has multiple options. What options do they get to see first? Okay. So whenever a supplier does that, or a manufacturer does that, and they pay that extra amount called a slotting fee, they expect that their product will gain prominence in the eyes of the consumer or the customer, and they're willing to pay for that extra advertising, if you'd call it. Okay, and that's where you'd see products at the very front of an aisle. If you go down, say, a bread aisle, there'll be certain brands of bread which are always towards the very beginning of the aisle. And the reason for that is that the manufacturer doesn't want their product to be lost amidst a multitude of different competing brands. Okay, so the layout for our retail environment, again, the focus is on the customer, but there's certain tweaks to that focus based on, is there any other profits that can derive from the manufacturer as well? Okay. Now, going back to the office space, and this could also apply to certain retail spaces, a modern trend we have these days, and that you see a lot when you go to the IT companies, is trying to blend a mix of your typical traditional office environment or retail space environment with a bit of home. Okay, and that refers to servicescapes, which basically try to give the customers, whoever they may be, a sense that they are in an environment where they can visualize themselves living in. Okay, and so this is pretty commonly seen, especially in businesses such as coffee shops. They try to have an environment where it's convenient, where it's pleasant to just hang around and do what you want to do without rushing you in and out as a traditional coffee shop might. Okay. Now, I'm going to, I wanted to talk about one last thing. How much time do we have on here? Oh, okay. we're running out of time, but I think it's important that I go over some calculations from chapter 9 that I think are important for you, especially as you try and work through the homework assignments and maybe any exam that we might have. Should have covered that as well. Okay, so when we look at process layouts are any layouts where the focus is not on the customer, but on the activities and how the activities flow into each other. Okay, and typical, like this here, where we look at an emergency room. And for whoever's planning an emergency room system setup, they have to take into consideration what are the different processes that somebody coming to that emergency room must go through to get from initial entry and admission to billing and exit, okay? And each and every case here in a process-oriented layout is usually not exactly the same. It could be, they're all emergencies, yes, but the type of emergencies differ, okay? Somebody with a broken leg might have a different set of requirements from somebody who requires the pacemaker to be repaired or replaced, okay? So we're interested here in basically figuring out what are the different activities, what activities do all people or different processes do all patients have to go through, and those should be put in places where it's easily accessible to every patient. And then there's certain activities that only a couple of the patients might go through, and not all of them. And those could be placed in places which are not immediately accessible to all the different patients who come in. Okay. So there's a method to the madness when it comes to how do we put together a layout for even a hospital, depending on the type of patients that the hospital expects to receive. Okay. Now, the process layout matrix that the book discusses here has to do with, if we know there's a movement of parts or movement of different loads between different departments, the question here becomes one of which of these departments here should we put next to each other, okay? And the same would apply to what we have with the hospital here. If we know we have different numbers of people coming in, which of these different processes should we have next to each other? So we don't have people coming in at the admissions, and then having to go to the pharmacy, then going to radiology, then going back to admissions, and going to surgery, then going to pharmacy, then to the triage room. I hope I said that correctly. And then finally exiting, okay? So a way to try and make sense of that whole system is to try and come up with a system that's based off of how much of each product goes from point A to point B, and then rearranging the system to make sure that there's some efficiency in moving product between the different processes that we're going to have. Okay, so figure 9.4 looks at the interdepartmental flow of different parts amongst 6 different departments. Okay, so if you're trying to read this here, we have starting with the department 1, which is assembly. We could have product move from assembly to paint, and or it could be assembly, the machine shop, or assembly to testing. Okay, so we have, in this case here, 3 different connectors to assembly. And I might want to figure out if I have a space like what I had previously. Okay, and the question here is that I want to cite my assembly process somewhere where it's easily accessible to the different other departments that require that product from my assembly, and also takes into consideration the number of loads. Okay, So the first thing that I notice here when I look at this is that the number of loads between assembly and the machine shop is pretty high. There's 100 loads that come from the assembly to the machine shop. So I'm thinking that if I was to do a first pass on this, my assembly, which is number 1, should be near the machine shop, which is number 3. Okay. Now, assembly and paint, there's also a pretty significant amount of product between the two. So I could maybe have paint over here. Now let's look at paint. The most amount of product that flows from paint goes to receiving. So I could have my receiving near paint. Paint at the machine shop. Machine shop is number 3. See, that's also pretty close. Paint and shipping, it's not as much. So shipping could be, let's say maybe I'd have my shipping here. Okay. The overall objective is that the amount of product moving between the different departments is minimized. Okay. So we are not covering a whole bunch of distances here. Okay. And then we could look at the machine shop. Now, once I get to 3 here, we're almost at, so our 3 has the most amount of material going to testing. So I could have 6 right by 3 over here. And there's also a link between the machine shop and receiving. So that link is already established there. And then when we go to receiving and shipping, 4 and 5 are right next to each other as well. Okay. So again, what we're trying to do here is minimize the amount of distance covered moving between the different departments that we have available here. Okay. And so you end up with something after trial and error, and the different ways of doing this. You could actually even set this up as a linear programming problem. But the overall objective is that you end up with a layout map that minimizes the total movement of product that you have, the different loads that you have in your system here. Okay. I guess we'll have to end here, but I have chapter 9 is pretty long. Might have to get a second. No, I think this is what I'll do. I'll make a video to cover this last part of chapter 9, which I think is very important, and that is balancing work cells. Okay. And balancing work cells is basically, we look at if we have a bunch of activities that the different employees do, okay, how can we ensure that the amount of work coming to every worker is equally balanced, such that we don't have one worker at his work cell doing 20 hours worth of work, while right next to him, somebody's only doing 3 hours worth of work, okay? So balancing work cells has to do with how do we, given that different workers do different tasks, how do we balance the amount of work that the workers do such that if we have a bunch of different workstations, let me get that, for example, here, okay? How do we ensure that the total amount of work done at every workstation, or maybe with every worker, is approximately equal, and we don't have a worker who's overburdened while some other worker has a lot of free time, a lot of idle time. Okay, and the same for the equipment that might be in each workstation here is how do we achieve a situation where the average amount of time utilized at a given workstation is approximately equal. Okay, so I will put a video out just covering this because I think it's important for you to figure out what is takt time, what is cycle time, how do we calculate the minimum number of workstations that we should have, and then how do we then assign employees or equipment to given workstations. Okay. All right. Any questions?
I think I'm good.
Okay. All right. So let's call it a day. And let me just very quickly check Blackboard to see that I'm not missing anything that you guys need to have. I need to get your cases, mini case studies back to everybody. I know I've not sent some back to some people, but I think we're good. All right. All right. You all have a good evening, and I'll talk to you next week.
Thank you, sir.
Thank you.
You'll take care.
Thanks.